Hello, everybody. Today we're going to be going over the fourth, I believe, question on the neetcode 150 list, or leetcode 49, group anagrams. And basically the question is, given an array of strings, strs, group the anagrams together. You can return the answer in any order. And basically, we see a few examples, but just to establish beforehand, an anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly at once. So we see here STRS is equal to eat, tea, tan, ate, nat, bat. And our output is bat, which is the only one that is an anagram of itself. Nat and tan, because when we rearrange nat, we can get tan. And same with 8, E, and T. We can rearrange each one of the characters in order to get one of the other. And we see here, we also have to remember that if these, I guess the array of strings is empty, then we return with an empty, I guess, list as well. Same with if we're only given one. So there's multiple ways, or at least we're only going to be going over two ways to solve this, just because there's not really many, like, I guess, alternate solutions. It's not a crazy problem, but we're going to go over the first approach, which is going to be sorting and brute force. All right, so as I said before, our first approach is going to be sorting, or through a sorting approach. So say we're given, I guess, well, actually, no, it's going to be an array of strings. It'll basically look like, let's just say for example, we'll say bed, um, bed, and Deb. Basically, with our sorting approach, is what we're going to do basically is take every single string and we will sort it. So BED will turn into BDE, and this will serve as our key in our dictionary. Oh, and that's another thing. We're going to be creating a dictionary, but we're going to be creating a default dict. And we'll go into that once I start programming it, but basically a default dict or a default dictionary is basically a dictionary that will automatically create a new empty list whenever we try to access a key that doesn't exist. So we wouldn't have to worry about any error that pops up or anything like that. Um, and basically we'll go through every single string in this array and add on to our dictionary. So our dictionary would hold the sorted version of bed. So this would turn into BDE. Just say BDE. And along with that, um, we will include every single value that, if sorted, ends up being BDE. So that includes bed and also includes Deb. Um, and basically, yeah, that's basically the approach that we're going to have with this. Is we're just going to sort each string in the array, and based on whether or not it is already in the dictionary, we will add that string into the dictionary. So fed would just be, or well, Deb would, yeah, def would be fed. Um, and it's the sorted version. And basically, once we get these values, we will return our, we're just going to return the values of whatever is in this dictionary. Because we don't really need these sorted versions. We're just going to return the the sorted, or not the sorted, but the unsorted values that correspond with each individual key. BDE being BED and DEB because once they're sorted, they become BDE, and FED being the value to the key DEF because FED sorted is DEF. And if there was another anagram of DEB, then it would be under DEF as well because if it's sorted, then it turns into DEF. So let's take a look at what that would look like in code. Okay, so let's go ahead and start our sorted solution. So we'll start out with a dictionary. And basically, before, remember when I said we're going to create a dictionary that will automatically create a new empty list whenever we try to access a key that doesn't exist yet? This is basically what that'll do. And we're also going to put an empty list inside just in case something like example 2 happens. And we'll go through every single string in strs. And we'll basically say our sorted string is going to be equal to um, I guess I forgot what these are called. These aren't quotation marks, but the thing that you use for like the characters, like in a string, you know? So basically we're going to make it join the sorted, I guess sorted version of the current string in the array. And basically this will you may be wondering why like we had this. And basically the point is to, because when you sort a string, like and say like s is equal to, I don't know, like AED or whatever, or like AED, yeah. When we sort it, that basically makes it, um, it'll sort it, but it'll look a bit different. So it'll look A comma E, or I mean D, sorry, sorted, comma E. So it'll more so look like this. But when we put this down, the two marks dot join, it'll basically join them together. So that'll basically make it so that it looks like, I guess, like together again. So that's the point of putting dot join right here. And that'll be our sorted string. And our res, which is our result, which is the thing we're going to be returning, or at least the values we're going to be returning. We're going to say the sorted string is going to be, I guess, appended, or at least, sorry, the key sorted, which is the sorted string for this array. We will append the original string, like basically attached to it. So as we said before, like ADE or AED would go into the AED key, and same with any other anagram of whatever that is, you know. And then once we're done with that, we return the listified, I guess, version of the values in our res. And this will be our solution for sorting. So honestly, it's a very simple solution, and it's very like it actually like works very well. Um, default dict as well. Uh, which is like very nice to have because we don't have to worry about there not being a key in the given moment, and we could just create a new key for whatever one that doesn't exist. But unfortunately, there's a reason why we're doing this first, and the time complexity of this solution will be m times n log of n. N meaning the length of the longest string, and m is the number of strings. So as I said before, whenever we do sort, um, it's most likely not going to have the best time complexity just because we're always getting log of n or log of m involved. And that's not a very optimal way to solve a problem. And there's definitely ways that we could cut out the fat, I guess, in a sense, um, to find the most efficient way of solving this problem, time complexity wise. So we're gonna go over another way of doing this that I guess uses the hash table more so, and it also compartmentalize every single character. So I mean, we'll take a look at it in a second. All right, so for our second approach, we are going to be using hash table. But honestly, more so, the approach to this problem is that we are going to assign every single character. So say we are given dab, um, bad, and I don't know, Len, I guess, or Les, big Les show, shout out. Um, so what we're going to do now, instead of just sorting it, which we could, but it's going to ruin our time complexity, is we are going to assign every single character a value, or not every single character a value, but we are going to count how many times a specific character has been counted. So we're going to create an array. I guess we'll call in this case like count. Basically, it'll have the count of every single um, I guess every single character, but it'll basically be its ASCII equivalent. So zero would be, I mean, I don't know if ASCII is, if zero is A in ASCII, but basically um, every single position will basically be like the number of occurrences. So this would represent technically zero, or I mean A, and then it'd be B, and then it'd be C, and then be D, and then it'd be E. If we were to go over a string such as dab, we would have 1A, 0B, or one B, I don't know what I'm talking about. 0C, 1D, 0E, and so on and so forth. But if you notice, actually, this string would be the exact same as um, bad right here. I don't know why that's why. That's there you go, bad. It's not bud. It's bad. So bad would have the exact same array as this, and basically we would append that to our dictionary or our hash table in this sense, or our default dict. We would append that, and we would append this as the same like key. So that would also be a part of it as well. So this is kind of our own way of sorting. It's like a cool little way of sorting, but basically how we're going to do it is, or at least in code form, is we are going to basically say the order of the current character, and then we're going to subtract that with the order of A. And you may be wondering like why we would do this or whatever, but say if 80 is A, right? And say C is equal to B, right? Or at least, you know, the character B. Basically 81, it literally be like, I don't even know if it's 81. I'm not gonna lie, I ripped that kind of from the neetcode tutorial, but say if it was 81, we would subtract it by 80 because B is one ahead of A. So that would just equal 1. That would be our first position in the the count dictionary, or not dictionary, the count array. So the first position um, would be basically representing a B, and we would basically add on to that. So um, it'd be one, so it'd literally just be like the count of one is plus equal one now. So each time we go through it and we find a character, we basically add that occurrence by one. And that's how we're going to track every single character. And once we could find the ones that are equal to one another, it'll just kind of do it on its own. Um, we'll just be appending each string a part of the key, which is the count value, or like the count array, because they'll have the same value, right? Or the same array. They'll have the same array. There'll be different, I guess, strings, but it'll be a part of the same, I guess, uh, it'll be a part of the same count array, basically. So let's take a look at what that would look like in code. All right, so we're back to LeetCode, and as you can see, I kind of forgot to run this in front of you guys, so I ran it just in case, and as you can see, the outputs are pretty much not the same, but it's basically the same. It's the same dictionary. It's just in different orders. Um, and now we're gonna basically, it's gonna be structured very similarly to our sorted solution. So it's gonna be res is equal to default dict, and make that a list. We're gonna go through every single string in STRS again. And now we're going to create our count array. So it's gonna look a little something like this, just because there are, I guess, 27 characters in the alphabet. And we'll basically be able to assign every single character with a number of occurrences with this. And we'll go through every single character in every string in the string array. And we'll basically say the count of the order of the current character, or I think it's, yeah, order of C. Yeah, that should be good. We're going to subtract A from it, so we get its default value, and we can basically plus equals one that. So if it is A, then it's going to be 0, right? The count of 0 is going to be equal to 1 if it's A. Um, it'll properly go through every single character in the alphabet and make sure that the corresponding position in the array is appended by 1 by the end of this, I guess, line. Um, and I guess that's really what you need to do for every single character. Outside of that, we get our res, or result, either or. And then what we do to count, so basically with lists, we can't really append them to a dictionary. So instead, we're going to create a tuple out of this. We're going to make count a tuple, and then we are going to append our string to our count, I guess, or our count array. So basically, like our string, let's say, because I like dealing with actual examples, like it gives you a better image of how this works. So say it's or say like the string currently is Vatican or whatever. Um, basically, the count is basically gonna look like, well, there's one occurrence of A, there's two occurrences of A, there's three occurrences of A, so it's going to be 3. And B, how many B's there are? 1 B. So it'll be 1 B. The amount of C's is 1. The amount of D's is 1 as well. And then so on and so forth. But this is going to have the exact same, well, I think I already explained that. But we're going to append the string. I guess we'll see the original string. Well, either or, we're not really sorting it. Jeez, my mind's all over the place. We're going to append the string as a value to this list key, which is a tuple. We've converted it into a tuple. But this tuple has a new value of the string that we have for it. And it'll basically go through every single string in the string array, and it'll continue to append the strings based on the count. And our count is basically going to be our key. Now once we're done with this, because now we're outside of the for loop, we're going to return the values of the dictionary or the hash table that we've created. Because once we're done, all we're gonna have is really just the values. If we were to just return the keys instead of the values, that wouldn't really make much sense because what's in the keys is the count array, or at least the count tuple now. So this just makes it's like it gives you all the values, and so you don't have to really worry about that, and it should work just as is. And yeah, you see here EAT, TEA, TAN, ATE. Output, it's basically the same. It does look a little weird, but I mean, it's the same dictionaries pretty much. But yeah, that's basically it. And also we needed to put in list before because this is now, uh, I guess we needed to just return it in the form of a list. And again, for this line, um, uh, yeah, it wouldn't really make sense if we were to just return the count with, because we're trying to find the values. I'm trying to find a good way of saying that this basically like bunches them up together. It bunches up all the strings in the string array that are anagrams of one another pretty nicely. It's basically our way of, I guess, sorting in a sense. But yeah, as we can see, it works pretty well here. And our time complexity, because I know you're dying to hear that, is basically going to be O of m times n. And as we said before, n is equal to the length of the longest string, and m is equal to the number of strings, of course, in the context of the list that we are given. So yeah, this is group anagrams, and yeah, this is the hash table way of doing it, and this is the sorted solution. Of course, we want to always avoid sorting, just because it's very it just ruins the time complexity most times. It's not to say that like you won't find sorting in the best uh I guess solution, but I guess especially for these like earlier problems, like you know neetcode 1, 2, 3, 4, 5, 6, whatever, you just won't really find sorting any list that you're given or whatnot like to be a very I guess efficient way of doing things. But yeah, that is group anagrams, and I'll see you guys for next video.